Learning objectives. At the end of this topic, you will be able to understand the concept of arithmetic progression, describe the sequence of arithmetic progression, evaluate problems based on sequence of arithmetic progression. Introduction. Let's begin this chapter with some examples. We've observed in nature objects such as petals of a sunflower, holes of a honeycomb, grains on a maize cob, spirals on a pineapple, etc. We notice that these objects follow a certain pattern. Now let's move to day-to-day like situations. Situation 1. A display of soaps in hypermarket consists of 15 rows, each containing 4 fewer soaps than the row below. Situation 2. Ravi has a salary of Rs 6,000 and an annual increment of Rs 700. Situation 3. A city sets a fine of Rs 500 for driving without helmet. This fine increases by Rs 200 for each subsequent offence. In the examples, we notice there is some pattern followed. We find that the succeeding terms are obtained by adding a fixed number. In others, by multiplying with a fixed number. In another, we find they are squares of consecutive numbers, and so on. In this chapter, we shall discuss one of these patterns in which succeeding terms are obtained by adding a fixed number to the preceding term. We shall also see how to find their nth terms and the sum of n consecutive terms. Consider the list of numbers and write your observations on the number pattern. 1, 2, 3, 4, and so on. 2, 100, 70, 40, 10, and so on. 3, -3, -2, -1, 0, and so on. In 1, each term is one more than the term preceding it. In 2, each term is 30 less than the term preceding it. In 3, each term is obtained by adding 1 to the term preceding it. In all the lists above, we see that successive terms are obtained by adding a fixed number to the preceding terms. Such a list of numbers is said to form an arithmetic progression, AP. Hence, an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. The fixed number is called the common difference of the AP. It can be positive, negative, or 0. The minimum information needed to know about AP are first term, A, common difference, D. If A1 is the first term of an AP, A2 is the second term of an AP, and so on, AN is the nth term of an AP, D is the common difference, then the AP becomes A1, A2, A3, and so on up to AN. So, A2 minus A1 is equal to A3 minus A2 is equal to, and so on up to AN minus 1 equal to D. We can see that A plus D, A plus 2D, A plus 3D, and so on represents an arithmetic progression where A is the first term and D is the common difference. This is called the general form of AP. In examples A to E, there are only a finite number of terms. Such an AP is called a finite AP. Also note that each of these arithmetic progressions, APs, has a last term. The APs in examples 1 to 3 are not finite APs, and so they are called infinite arithmetic progressions. Such APs do not have a last term. For the AP, 3, 1, -1, comma minus 3, and so on. Write the first term 1 and the common difference d. Let's view some examples. Find the AP whose first term is 4 and the common difference is minus 3. Summary. Let's summarize the topic. The succeeding terms are obtained by adding a fixed number, in others by multiplying with a fixed number, in another we find they are squares of consecutive numbers, and so on. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except for the first term.